Hi, and welcome back to HeFPipe. In this video, we're going to talk about the correlations that HeFPipe conducts on your trait data. So, continuing exactly from where we left off in the previous video, you may not have noticed that there was quite a bit of output in the terminal window here after the pipeline finished running the RHH module. So most of this output can be ignored, but for your information, what's happening here is that the pipeline is conducting correlation analyses on the trait data that you provided in the acceptor.csv file over here, or whatever your equivalent is in your dataset, as well as on the multi-locus heterozygosity values that we generated in previous steps. So the pipeline first generates a correlation matrix heat map of all of the traits, and that heat map is called heatmap.pdf. And it gets stored in a new subdirectory of the pipeline directory called, aptly enough, correlations. So if you open heatmap.pdf, this is what it looks like. And you can see it's just a trait by trait correlation matrix where the colors correspond to the strength and direction of correlation. It also generates a file called allcorrelations.csv, which contains Pearson and Spearman correlation coefficients for each pair of traits in the trait value spreadsheet, and then including the multi-locus heterozygosity estimates as well. P-values for each correlation, as well as p-values adjusted for multiple comparisons using the Benjamini-Hochberg correction, are also listed in these columns here and here. These two columns are the adjusted Pearson and Spearman, and these are the p-values of Pearson and Spearman before adjusted, and these are obviously the actual correlation coefficients. Then a PDF called CoreChart Pearson PDF is generated. It looks like this. And this PDF is basically a matrix where the diagonal cells, so these, contain plots of the distribution corresponding to each trait. So here, for example, if we zoom in a little bit, is the distribution of initial queen weight, which is one of the trait values in the example dataset. And then the cells in the lower triangle of the matrix depict scatter plots using the traits corresponding to the row and column of that particular cell as the x and y values. So in this case, we're looking at this particular cell right here. This depicts a scatter plot using between queen weight initial and queen size, which in this case is called PC1, which is just a principal component of size. It's another one of our traits. So basically, this is a scatter plot between these two traits. And the cells in the upper triangle of the matrix depict Pearson correlation coefficients between, again, the two corresponding traits in the same way. So reflecting across the diagonal here into the upper triangle, this is the correlation coefficient between these, this is the correlation coefficient between these two traits. Now, uncorrected significance is depicted as red dots and stars, such that 4 red stars, corresponds to a p-value of 0, and then 3 red stars corresponds to a p-value of 0.001. Here's an example of that. And then 2 stars corresponds to a p-value of 0.01. Here's an example of that. And 1 star corresponds to a p-value of 0.05. Here are several examples of that. And then a dot basically represents marginal significance with a p-value of 0.1. I don't know if we have an example of that in the example data set. Oh, here's one. So again, I just want to emphasize that these are uncorrected p-values. So this is ignoring correction for multiple comparisons. Another PDF file called CoreChart Spearman PDF, which I'll open here, is generated the same exact way and has all the same exact properties as the chart that we've just talked about, excepting the Spearman correlation coefficients replace the Pearson correlation coefficients in the upper triangle of this matrix. So again, this file doesn't have corrections for multiple comparisons applied to the p-value. So in addition to listing the p-values adjusted for multiple comparisons in all correlations.csv, which you should be aware, these values are actually transformations. A transformation has been applied to them, to the p-values themselves. So these are not obviously the same p-values here. They're basically, they've been transformed by the correction. But if you're not interested in the actual transformed p-values, the pipeline also generates another file, and this file is called fdr_cutoffs.txt. And if you look at that here, it shows you the unadjusted p-value that represents the new significance threshold after correction for multiple comparisons, both Pearson and Spearman. Here is the new, basically, p-value assuming a 5% false discovery rate. Okay, the last 4 items that we're going to talk about in this video are generated by the pipeline in the correlations directory still. And they're all CSV files, and they largely match the format of the correlation charts that we've just discussed, in that they contain matrices with the trait name in the diagonals. Let's open one just to get an example. So the trait names are listed in the diagonals. Oops, that's not diagonal. And the correlation coefficients are listed in the upper triangle, same as before. So these are all correlation coefficients. In this case, they're Pearson correlation coefficients. But the lower triangle now contains p-values corresponding to the correlation test between those two relevant traits again. So here, as an example, is the p-value of a significance test between proportional queen weight loss and the number of days it took for the first worker to a close, which again are just 2 fitness traits in our example data set. The 4 files correspond to Spearman and Pearson correlation coefficients, both with and without adjusting the p-values for multiple comparisons using a Benjamini-Hochberg method, assuming a 5% FDR. And each file is labeled accordingly. So here you'll see a correlation Pearson, a correlation Pearson adjusted, correlation Spearman, and correlation Spearman adjusted. And that's it for this installment. Stay tuned for more of the pipeline.